In this video, we are going to talk about trig function values of various angles. So let's take a look at what we know from topic 3.2. We know that cosine theta is a x over r, sine theta is a y over r. And r is the radius of the circle. And if I solve for x, I can say it is r cosine theta, x is y is r sine theta, which means my x and y coordinates are, we are looking at in terms of sine and cosine. Now remember, cosine is always adjacent, which is always a horizontal, which is always the x coordinate. Sine is always the vertical, which is the opposite, and it's always the y coordinate. So this will simplify so many values of trig values on the unit circle, because all we have to know is we keep moving the point P on the unit circle based on the angles. So let's take a look at this example here. Figure above shows the circle here above means on the side with a radius 4, and you have to pay attention to the angle equilateral triangle. Equilateral triangle means all the angles are same. So this is a same angle. All these angles are same. And now you know that on the triangle we have a 180 degree. 180 degree, all the three angles are same. That makes it 60 degree. 60 degree is the same as a pi over 3, which means this angle is a pi over 3. Now read again carefully. What are the coordinates of point Q? Which means I need a coordinates of point Q. Many students are rushing to answer the questions as soon as they see pi over 3 point P and they choose the answer A, which is not the case. If they says point P, then the answer is A. Here they are asking for point Q, which means 2 pi over 3, and this is a x coordinate is a r cosine theta, r sine theta. Remember, this AP Pre-Calculus exam is about multiple choice questions and lots of words and very similar looking answers. And we have to get ready for the how to deal with multiple choice questions. So now here, let's take a look at another question here, which is not a multiple choice. You have to get the answer. Figure here shows the circle with a radius r. And you are given two coordinates, 6 root 2 and negative 6 root 2. So first thing we understand that these two numbers are same, which is a right in the middle, 45 degree, which is 3 pi over 4. Now they are not asking for the angle here. They are asking for what is the value of r, radius. You have to know the coordinates, which is x and y. So always draw the picture on this triangle, on the circle, always label. We know the Pythagorean theorem is x square plus y square equal to r square. You have to be very, very careful about negative number square and radical square. 6 root 2 square, which is, if any times you are in doubt, write 6 root 2 and 6 root 2. Write it twice. Root 2 times root 2 makes it 2, and 6 times 6 makes 36. Now negative 6 is a negative number square is again 36, and 36 times 244. 6. If you add both of them together is 144, and square root of 144 is a 12, which means radius is a 12. No, before you ask that, can you allow calculator? No, these questions are always without calculator, and you are expected to know the basic values of the squares, square roots, and radicals, and all this you are expected to know. Okay, so let's take a look at some more examples on here. This says consider the unit circle above with the points P, Q, R as label and find the values of the following. Now, if you look at these points, they are sitting right on the axis. Now, any angle sitting right on the axis, for example, here Q, and P and R, we have a special name. We call them quadrantal because you don't know which quadrant it goes into. They are right at the border of the quadrant. Like this is a first quadrant. But if it is sitting right at the border, how do you know whether it's quadrant 1 or quadrant 2? So that's why we call them quadrantals. They are very helpful because always one of the number is always 0. So let's talk about cosine 0, sine 0. So if you know those coordinates, always 1 and 0, cosine and sine, radius is a 1 because the coordinate is 1. So quadrantals are your best friend. I love them. I love them because answers are either 0 or 1 or negative 1. Later, when we talk about the slope, then you can see that the slope of the horizontal line is a 0, slope of the vertical line is undefined. So if I have to find tangent over pi over 2, I have to say it's undefined because it's a vertical line and the slope is undefined for that. So quadrantals are again your best friend. So easy. Cosine sine, always, 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 always label on the circle. Many times students are mixing up between a sine and cosine. So always write C comes before S, which means X comes before Y. And always X is a cosine, Y is a sine. So let's talk about sine, cosine of other numbers. A large portion of this course requires that we can find numerical values of functions involving sine, cosine at important angle values. Now, important means I call them special ones. Special numbers are always pi over 4, pi over 3, pi over 6, pi over 2. Basically 30, 60, 45 degrees. But we call them special angles and they are multiple of those numbers on the unit circle. So how do we find values? So let's take a look at here, this circle here. And one more time, you have to know the idea about equilateral and isosceles. If you see the word equilateral, equilateral means right away you have to make a connection that this angle is 60 degree. This angle is a 60, that angle is a 60 for our understanding. We are not using degrees for our understanding. Now this 60 degree triangle, if I cut in half, so that makes it 30 degree. 30 degree is 5 over 6. Then you are supposed to know and memorize those sides. How do you know that this is 1, this is 1/2? So again, 60 degree means these three angles are same and three sides are same. This is radius is 1, this is radius is 1, and you are cutting in a half. That makes it 1/2. So then how do you know that this is root 3 over 2? Well, you can use the Pythagorean theorem. 1 square minus 1/2 square is 3/4. And when you take a square root of 3/4, you get root 3 over 2. Or you can go back to geometry class or algebra 2, how you memorize those special triangles. Now remember, we are going to put this triangle inside the circle. So that means you have to divide everything by 2. And that makes your horizontal coordinate, which is a larger one, root 3 over 2, which means cosine and sine, which means cosine pi over 6 is root 3 over 2. Sine pi over 6 is a 1/2. And this clearly says everything together here, how we did and how I explained 1 square minus 1/2 square. I talked about 3/4. So take a square root, and that's a positive side, that's a negative. This is a first quadrant, so x is positive. And these are my coordinates. So what this means is cosine pi over 6 is root 3 over 2, sine pi over 6 is 1/2. Know this. These are called special triangles. Either way you memorize, you have to have a really, really good speed on this as well. This has to become a muscle memory. So that was about pi over 3. Now let's talk about, that was about pi over 6. Now let's talk about other angles. Okay, so using symmetry, this would be if you reflect in a second quadrant. For example, your point is here, and if you reflect in the second quadrant, so like I talked about in the section 3.2, this is you are cutting in a half, 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 half. So 1, 6, 2, 6, 3, 6, 4, 6, 5, 6, which is 5 pi over 6, which is in this quadrant. Point Q is a 5 pi over 6. So this is pi over 6, 5 pi over 6, 7 pi over 6, 11 pi over 6. And this is your pi. So again, think about one less, which is 5, 6, one more 7, 6. And all the points are basically reflection over the axis. In other words, this is your cosine, sine, cosine, sine, cosine, sine, cosine, sine. And you need to know these values, which is first is cosine, this is sine. What this means is cosine pi over 6 root 3 over 2, sine pi over 6 1 half, and all those angles. Do you have to know this? Yes. You do have to memorize this? I wouldn't say memorize. I would say you must understand and know how to reflect across the axis. Because all you have to know is the first quadrant. And then you keep reflecting over and over. So here we talk about pi over 4. Pi over 4, which means 1 pi over 4, 3 pi over 4. Remember your pi is here. So 1 less is a 3/4, 1 more is a 5/4. Two numbers are same, which means angle is 45 degree. And here the buzzword is isosceles right triangle, not equilateral. Isosceles right triangle, which means two sides are same. And these two angles are same. Isosceles right triangle means 45 degree and pi over 4. So what are the values? So let's talk about how to get those sine and cosine numbers. If these two numbers are same, so we can say x square plus x square is a 1. And take a look at here how we derived up to these two numbers. And if you have remembered from the knowledge from algebra 2, which is also fine, we call them 1, 1 and root 2. 1, 1 root 2, which is the same as you divide by root 2, and that makes it 1 over root 2, 1 over root 2, and 1. Something you have to know for this curriculum is how to rationalize. I talked in the class that 1 over root 2 is okay if you write it. You will not see this as our answers. You must rationalize. What is rationalize means? You multiply, divide by root 2. Here, I showed here, multiply, divide by root 2 because radicals are not allowed in the denominator, which means you multiply, divide by root 2. Root 2 times root 2 is a 2, and that is 1 times. So if you write like this, okay. Multiple choice questions, we use this. So you must know they both are same. You must know they both are same. Now let's talk about the last thing about pi over 4 quadrants and the coordinates, which is a cosine and sine. Two numbers are same, which means pi over 4. Two numbers are again both negative. That means third quadrant. And you know that x and y coordinates. So you are supposed to know all these coordinates of those points as well. Okay, so back to the equilateral triangle. Yes, equilateral triangle means 30 or 60 degree. Now watch out here. The picture shows here, this is equilateral triangle. The location of the triangle is different. Notice that they both says equilateral triangle. I'm pointing out again one more time. Here, this equilateral triangle, the triangle is sitting this way. That makes it pi over 6. But in this case, equilateral triangle, triangle is sitting on the north, which makes it this angle pi over 3. So count again. This is your pi. 1 less 2 pi over 3, 1 more 4 pi over 3, and you have to, all you have to do is reflect the coordinates. Now remember another thing, pi over 3 is a bigger angle. So sometimes I use the word small, medium, large. Pi over 3 is a large angle. Large angle has a larger slope, which means y coordinate is a bigger. Pi over 6 is a smaller angle. So I call this a small angle has a smaller slope, which means angle is a small, y coordinate is a smaller. That's how you differentiate. And pi over 4 is considered the medium angle, which means ratio of two numbers are same, which means slope is 1. So it's so much easier to refer to small, medium, large. Large means large angle, pi over 3. Slope is the biggest number, which means the y is a bigger number, x is a smaller number. If you keep small, medium, large, your life would be so much easier. So now here, all of them together, easy way to remember all the triangles together. So pi over 6, I mean, 0 is the smallest one, of course. You can't really sketch the triangle. This is a quadrantal, so you can say that the coordinates are 0, 1, and 0. And then the angle gets bigger and bigger. Notice that the y value increases and the slope also increases. So pi over 6, pi over 4, which is this is the small angle, this is a medium angle, this is a large angle. Now pi over 2 is a 90 degree and the slope is undefined, which is the y value is the biggest because coordinates are, remember, 0 and 1. So this is the largest y value. This is the largest x value. So as you go from left to right, sorry, not left to right, counterclockwise, the y coordinate increases, which means sine theta value increases, cosine theta decreases. And this is the easiest way to remember all the triangles and their numbers. Small angle, small side, medium angle, same side, large angle, large side, and again largest is pi over 2. I hope this helps you to understand all those angles in radian measures and their trig values. Thank you.